move to the next point, we should ensure that whatever we see is clear.
That means work is being done, we can see that it is in opposite direction. It is against the
Good day, my learners. My name is Ibrahim Omar. You are welcome to another edition of Ministry of Education Kaduna State Radio, Television, E-Learning program. Today in chemistry, we are taking water, solution, and solubility, part 2. The course is broken down into treatment and supply of municipal water, solution, under which we look at true solution, false solution, and suspension. Then we look at solubility, under which we study saturated solution, unsaturated solution, and supersaturated solution. Then we conclude the lesson with solubility curve. My students, I believe you can remember the first topic in which we discussed water, and we agreed that water is a compound that consists of 2 atoms of hydrogen and 1 atom of oxygen with a chemical formula H2O. We discussed the physical properties of water, in which we agree that it has a melting point of 0 degrees Celsius, a boiling point of 100 degrees Celsius, it is neutral to litmus paper, and then it has a maximum density of 1 grams per cm cube at 4 degrees Celsius, and so on. We talk about the chemical properties of water, in which we agree that water reacts with both metals and non-metals. Water also reacts with metallic oxides and non-metallic oxides. It also acts as oxidizing and reducing agents. We talk about hardness of water, which is the reason why it will be difficult for water to form lather with soap sometimes. Today we are building on that, and we start with treatment of water for municipal supply. I want to believe that most of you have used tap water, and there are a lot of things in tap water. I believe you know there are processes in which the water will follow before it is sent via taps. The processes are as follows. We agree that the pipe-borne water used in towns and urban settlement is prepared in the water treatment plant, which we call water boats generally. And the water is to be germ-free, and it contains essential minerals and solutes for your consumption. To achieve this, there is a sequence of processes it follows. Number 1 is aeration, followed by coagulation, then sedimentation, filtration, and finally disinfection, which is the addition of chemicals. How do we achieve this? First of all, water is collected from various sources, such as the lakes, the rivers, and possibly even the rainwater, and it is stored in reservoirs or dams, which are allowed to be opened for it to mix properly with oxygen. That mixing with air will remove bad odor, and the process is called aeration. Secondly, alum is added to the water in settling tanks. This alum is a compound of potassium aluminium tetraoxosulfate 6 or sodium aluminate 3, that is NaLaO2. And then it is added to the water to make coagulation. Coagulation is the process in which the water will flock together to form big lumps of dirt. And these big lumps will enable the water to settle rapidly. That settlement is what we call sedimentation. And then, if that happens, then the water is sent into filter beds. And the filter beds will remove the remaining fine particles of water. Then finally, there is addition of calculated amount of chemicals, which include chlorination, that is addition of chlorine to kill germs. We have iodine that is added as food supplement and also to prevent goiter. We have fluorine, which is added as a food supplement and also to avoid tooth decay, and it gives you a refreshing smell and taste. And then also we add calcium oxide, the process we call liming. This liming can take place in 2 ways. We have what we call pre-liming, that is, it is added in the coagulation process, and sometimes we also add it at the end when the water is properly treated. And this has 2 important functions. Number 1, it is added to correct the hardness of the water. And then secondly, it will give it a correct pH, because water should be in alkaline medium for a proper consumption. Then the treated water is now is now stored in the reservoirs where they are distributed into the towns through pipes and other things. And it is important to take note of the fact that whenever you open your tap, the first thing you hear is a kind of a sound that is coming out from the tap. And that sound also, you hear that it has a refreshing smell. That is because chlorine is added to kill all the germs before the water is being transported. So anytime you open and then the sound is not heard, that is to say that possibly there is a leakage in your pipe, and then possibly the chlorine must have escaped. But a proper water that for good consumption should have that chlorine, and that sound should be felt. Which is solution. Before I continue, you have to know that mixture are generally classified into two. There is what we call homogeneous mixture, and there is heterogeneous mixture. A homogeneous mixture is the mixture in which all the substances are in the same state of matter. Example, when you dissolve salt in water, you agree with me that it will completely mix and then the salt will completely disappear. That's a homogeneous mixture. Then, if you have chalk powder and you add it to water, you realize that you'll be seeing the chalk powder in the solution. That means this is heterogeneous because the chalk powder remains in solid form and then the water is in liquid. So having said that, I'll move into solution. Now, whenever you have homogeneous mixture, then you have what you call solution, because a solution is defined as a homogeneous mixture or a uniform mixture of two or more substances. And then a solution is always made up of what we call a solute and a solvent. A solute is the particles that is dissolved, while a solvent is the particles that dissolves the solute. It is important to take note of the fact that usually the solvent is always the larger part of the solution. Having said that, then we'll go into two types of solution that we have. Number one is the true solution, and number two is the false solution. Now, what is a true solution? A true solution is a homogeneous mixture in which the solid completely dissolves and cannot be seen with the naked eyes in the solution. That is a perfect example of what I gave you. Solution of sodium chloride in water, which is your common salt. When you add it to water, it will completely dissolve and you will not be able to see the salt. Usually, the size of the solute, dissolved solute, in a true solution is between 0.01 nanometer to 1 nanometer, which is 1 times 10 raised to the power of -6 meters. That's a very small size, and you'll not be able to see it with your eyes. Then we have what we call the false solution. The false solution is also called colloidal solution. In colloidal solution, it is also a homogeneous mixture. The solute will dissolve, and you'll not be able to see it with your naked eyes. But the difference between the true solution and the false solution is the fact that the sizes of the particles in false solution ranges from 1 nanometer to 1,000 nanometer. That means it is bigger than that of the true solution. A perfect example is a starch solution. Now we have types of these colloids or colloidal solution. It is important to know that in colloidal solution, the solvent is called a dispersed medium, while the solute is called the dispersed substance. So the types are, one, we have sol and gel. Now, when a solid particle is dissolved in a liquid medium, then the resulting colloid is called a sol. And then under certain conditions, when the sol is solidified, then it becomes gel. A good example is the starch solution given. Other examples include glue, jelly, gelatin, and so on. Then aerosol, which is the second type of colloid. Aerosol, it is a liquid or a solute that is dispersed in a gaseous medium. A perfect example is smoke. You see that the particles of smoke are solid, but they are dispersed in air, which gives you what we call aerosol. And then we have emulsion. In emulsion, it is liquid that is dispersed in another liquid medium. Example is the milk solution, and so on. Cod liver oil, hair cream, etc. Having said that, we go into suspension. Now, what is suspension? A suspension is a heterogeneous mixture of solutes in a solvent. the undissolved particles of solute are large enough to be seen with a naked eyes. That means in a suspension, you'll be able to see the undissolved solid particles. A perfect example is what I gave you as chalk powder dissolved in water. You'll be able to see the chalk powder or the solute of the salt. Now, it is important to take note the difference between true solution, false solution, and suspension. In terms of size, you know that a true solution has the size of the particles less than 1 nanometer. Then the false solution has the size of particles between 1 nanometer to 1,000 nanometer. And then the suspension, the size of the particles are greater than 1,000 nanometer. My students, having said that, we'll go into solubility, which is the third aspect of the course. Now, what is solubility? A solubility of a solute in a solvent at a particular temperature is the amount of solute, either in grams or in moles, that will saturate 1 dm cube or 1,000 cm cube of the solvent at that particular temperature. That means in terms of solubility, solutions will be grouped into 3, or they are generally grouped into 3. 1 is the saturated solution, 2 is the unsaturated solution, and 3, supersaturated solution. Now, it is important to take note of the relationship or the formula that is used in calculation of solubility, because I said that solubility is the amount of solute in grams or in moles. Then 2 formulas will be given, either to ascertain the solubility in grams per mole or to ascertain the solubility in moles per dm cube. Now, first, solubility in moles per dm cube is given as the amount in moles all over the volume in cm cube times 1,000 at that particular temperature. Now, if you are able to convert the volume from cm cube into dm cube, then you will not need to multiply by 1,000 because it is a factor of 1,000. That is the conversion factor. Then if you are calculating the solubility in grams per dm cube, then the formula is given as solubility in grams per dm cube is equals to mass in grams all over volume in cm cube times 1,000 at the given temperature. It is important to note that solubility in moles per dm cube is related to solubility in grams per dm cube if you know the solute. That is, with the formula that solubility in moles per dm cube is equals to the solubility in grams per dm cube all over the molar mass of the compound given. Having said that, my students, I'll go into the definitions of saturated, unsaturated, and supersaturated solution. Now, in a solution, when you add a solute in a solvent, you add it in 3 different ways. The first way is you can add a very small quantity of solute in which more solute can be required in the solution. Or you can add the maximum amount of solute that the solvent requires. Or finally, you can add even more than is required. So if that happens, you have unsaturated, saturated, and supersaturated solution. Let me elaborate. A saturated solution of a solute at a particular temperature is one which contains as much solute as it can dissolve at a given temperature in the presence of undissolved solute particles. That is, you continue to add the solute until when it gets the maximum amount of solute required. Then the solution is said to be saturated. 2, unsaturated solution is a solution in which it contains less solute that it can dissolve at the given temperature. That means for unsaturated solution, you can make it saturated by adding more solute in the solution until when it is saturated. So we have less solute in unsaturated solution. And finally, supersaturated solution is the solution which contains more solute than it can hold at the given temperature. That means it is saturated and you still add more solute. So you see the solid particles that you can only shake and they will be out of the solution. My students, we go into solubility curve, a very important concept. Now, what is a solubility curve? A solubility curve is a graph which shows the solubility of a solute against the temperature. That is to say that the solubility is given on the vertical axis and then the temperature is given on a horizontal axis. Now, it is important, if you want to compare the solubilities of different solutes at a given solvent, then you can have several solutes and you plot them on the same axis. A perfect example is given. This is a graph of solubility. You see, it is the solubility in grams per 100 grams of water for different salts. And then this is the temperature, that is start from 0 to 100 degrees Celsius. From the graph, you can see that this is a curve of sodium chloride. And the curve is almost vertical. And when you have a vertical line, that is to say that the solubility is independent on the temperature. Even if it is at 0 degrees Celsius or at 100 degrees Celsius, the solubility will remain virtually the same. Then in a situation like potassium trioxynitrate 5, you see that the graph is tending to be horizontal. Then when that happens, that means temperature has a high effect on the solubility. Increase in temperature makes more solids to be dissolved. Now, a similar equation can be given. You'll be given graph and you'll be asked to calculate the solubility. All you have to do is to trace. Example, if they ask you what is the solubility of potassium trioxynitrate 5 at 40 degrees Celsius, all you have to do is to use your ruler, trace 40 degrees Celsius, take it to the curve of the salt, and then trace it back to the vertical axis, and that will give you the exact amount or the concentrate or the solubility of that salt. My students, having said that, we can go. This is another graph because we have more salt here, and you can see the various differences between the solubility of the substances. Then we'll go into applications of solubility curve. How are they important? These solubility curves are very important because, one, it helps pharmacists to determine the amount of solid drugs that must be dissolved in a given quantity of a solvent to give a prescribed drug mixture. That is, if they want to give you a mixture, you would have to use the solubility curve to know the amount of water that is needed or the amount of solvent that is needed. Also, in extraction, it helps researchers and chemists to determine the suitable solvent at various temperatures used for extraction of metals or other chemicals from natural sources. It also helps in separation of purification of mixture by using fractional crystallization, because in this case, the solid that crystalline first is the one with the lowest solubility. My students, I will give you an example, a solved problem to take note of calculations under solubility. The question is, if 6.1 gram of sodium trioxynitrate 5 were dissolved in 30 grams of distilled water at 50 degrees Celsius, calculate the solubility of the solute in moles per dm cube. The question again, if 6.1 grams of sodium trioxynitrate 5 were dissolved in 30 grams of distilled water at 50 degrees Celsius, calculate the solubility of solute in moles per dm cube. The masses are given: nitrogen is 14, oxygen is 16, and sodium is 23. Now, solution. The first thing that you are expected to do is to calculate the molar mass of the given salt. And if the salt is sodium trioxynitrate 5, that is NaNO3. The mass will be 1 sodium plus 1 nitrogen plus 3 oxygen. That is, substitute the masses of nitrogen, sodium, and oxygen. You have 23 plus 14 plus 3 times 16. You start with the times using BODMAS. You have 23 plus 14 plus, now 3 times 16 will give you 48. Plus 48. Now, when you add 23 plus 14 plus 48, you end up having 85 grams per mole. Now, the amount in moles of sodium NO3 is given as the mass of the salt all over the molar mass times the amount in mole all over the molar mass, which is given as 6.1, which is the mass given, all over 85, which is the molar mass calculated. Then when you do the division very well, you end up having 0.072 moles. Now, at that 50 degrees Celsius, we know that 0.072 moles of the salt dissolve in 30 grams of water. Now remember, that gram is the same as cm cube if we are comparing water. That means 100 grams of water is equals to 1 dm cube. That is to say, 1 gram is equals to 1 cm cube. So now, using the ratio proportion method, we end up having x is equals to the amount in moles, which is 0.072, times 1,000, which is the factor, all divided by 30, which is the grams of water given. And then when you do your calculations very well, you end up having 2.39 moles per dm cube. My students, I believe you have learned. Take care of yourself as I invite my colleague, Mr. Philip Mammon, to give you a brief summary as well as work to keep you busy. Stay home, stay safe, and keep learning. Thank you.
My wonderful students, I'm sure you have enjoyed the beautiful presentation by my colleague, Ibrahim Umar. I'll be summarizing some of the issues he raised. Most importantly, I'll be looking at the treatment and supply of municipal water. He did outline that there are steps involved: aeration, coagulation, sedimentation, filtration, and bacteria treatment. Now, bacteria treatment is to destroy the germs. It can be by chlorination, as he has mentioned. It can be by UV and so many other methods. But I would like to emphasize that for exam's sake, if you are asked to outline this procedure, you should outline them sequentially for the maximum mark. If you don't outline them sequentially, you will get a maximum of 3 marks instead of 5. So it's important that you take note of that. We also talked about the type of solution. As we say, there is true solution and there is false solution. He mentioned homogeneous mixture, in as much that the solute is evenly distributed or uniformly distributed in the solvent, such that the eyes cannot differentiate between the solute and the solvent. But of course, for the false solution, you can see that the particles are not evenly distributed. So you can use your naked eye to differentiate the particles, even though he mentioned things like colloidal solution, which your eyes cannot separate. But of course, suspension, you can see the particles floating on the solvent as well as the solvent below the solute. Solubility, he mentioned solubility as the amount of solute, either in grams or mole, that is dissolved in 1 dm cube or 1,000 centimeter cube of a solution at a particular temperature. It's important that you know that it's at a particular temperature. And that is why there is solubility in mole per dm cube and there is solubility in grams per dm cube, such that solubility in mole per dm cube is amount over volume in centimeter cube times 1,000. Remember, the 1,000 is a factor that converts centimeter cube to decimeter cube, meaning that if you have converted your centimeter cube to decimeter cube, there is no need to multiply by 1,000. Also, solubility in grams per dm cube is the mass over volume in centimeter cube times 1,000. Saturated solution is a solution that contains maximum solute, as much solute as it can dissolve at a particular temperature, in presence of undissolved solute. Remember, at saturated solution, this undissolved solute is at dynamic equilibrium with the solvent. It's very, very important for you to note that. And when you say a solution is unsaturated, it means it does not have enough solute as it can dissolve. And when you say it is supersaturated, it contains excess solute as it can dissolve. Solubility curve is very, very important in chemistry. It shows the relationship between solubility and the temperature under the solubility took place. So I'll quickly look at our assignment for today's lessons. It's very, very important for you to go through them to find out whether learning has actually taken place. First, it says, explain the process of water treatment for town supply. Another name for town is municipal, so don't get confused. It can be municipal, it can be town supply. The second question says, what are the functions of the following chemicals in water treatment? 1, chlorine in the process chlorination, fluorine in the process fluorination, iodine in the process iodination. Number 2 says differentiate between true solution, false solution, and suspension. Number 3 says define the following terms. A, solubility. B, saturated solution. C, unsaturated solution. And D, supersaturated solution. Number 4, it says if 2 grams of potassium chloride is required to saturate 200 centimeter cube of water at room temperature, what is the solubility of the salt in mole per dm cube? You have the relative atomic mass of chlorine to be 35.5 and potassium to be 39. If you apply the formula that we gave you earlier, I'm sure you'll be able to resolve this calculation, and we'll be happy to receive your feedback in the contacts I'm going to present to you as the class concludes. Ibrahim Umar, the earlier presenter, his phone number is 070-3620-2842. I'll take it again. Ibrahim Umar, 070-3620-2842. Mr. Williams Ishaku, 081-6067-0920. Williams Ishaku again, 081-6067-0920. And of course, Mr. Philip Maman, 080-2659-8861. 080-2659-8861. It has been my pleasure with you. I'm still your chemistry teacher, Mr. Philip Maman. See you again in another class. Remember to stay safe, stay at home, and keep learning. Have a wonderful day.